Hello there, welcome to another video of Augmented Reality. This is my 5th episode in AR. If you haven't watched my first 4 episodes, provided its link in my video description, go through it for full complete course. So what we expect at the end of this video is we are trying to make a similar functionality which is already made in YouTube for a body tracking example with Swift UI, RealityKit and AR4, but it is made fully in Playground. So what makes the difference is I'm trying to make the similar function with Storyboard and Swift5 from scratch. So let's start doing it. First of all, I'm going to search for Xcode in my system, right? So I'm going to create a new Xcode project, and here you can select which platform you need to make it. So I'm going to select here Augmented Reality app. Click next, and you can name the product here. So I'm going to name here as body tracking skeleton. It's an example, alright, and the content technology will be of a RealityKit. I'm using here user interface as Storyboard, and the language is Swift. So click next, and you can save wherever you like. I'm going to save it in my iOS projects, and let's create that. As soon as you create it here, you can see here there is already a viewcontroller.zip file and also main.storyboard, which is connected already to an AR screen. Here we go. So it's already a default AR view is in our view controller, and it's connected to our viewcontroller.zip file, and there inside this you can find here with viewed load with the loaded box example, which is provided by Apple itself as a default. So first of all, what I'm going to do is I'm going to delete this RC project because we are not going to use it anymore in our project. So click that delete, so it's moved to trash. And also let's come back to the viewcontroller.zip file and remove these lines, and we're going to start from here from scratch. So first of all, what I'm going to do is I'm going to import here ARKit. This is the first step, and then I need to initialize a AR session, which is for AR session delegate. So that session delegate, it's nothing but we need to update each moment. So it's a live tracking, so we need to update each moment. That's why we are using this AR session delegate method. All right, and then first of all, I'm going to initialize 2 of the variables which is going to use in our project, which is for a body skeleton. Let's say var body skeleton. Var is nothing but a variable which I'm going to declare here at the initial stage. So it's var skeleton, and that will be of a body skeleton. And next line, I'm going to write here a var, which is for a body skeleton anchor. I'm explaining here about the anchor and all the stuffs in my previous videos, so you can go through it if you are not familiar with what is entity and all those stuffs. So let's say this declaring as an anchor entity, which is of an object which I need to track there. So after this, actually there's no scope for body skeleton. We're going to declare this later on. And first up is another thing is I'm going to initialize this viewed load with the body tracking. First of all, we need to check how to handle this body tracking in our app, which means whether it's supported or not. So let's say got AR body tracking configuration dot is supported or not, which means we are checking with the device it's supported or not. If it's supported, let's say it will go on, otherwise it say, oh no, this device is not going to support this feature of AR. So what I'm going to do is I'm going to print here device is not supported, not supported. So try to run this project in a real device also. You need to make sure that it's having iOS 13 above OS as well. Alright, so after this, what I'm going to do is I'm going to run body tracking configuration, which is for to track the body initialization actually. So run a body tracking config, and here what I'm going to do is let's say let configuration will be equal to AR body tracking configuration, and then AR view dot session will be running dot run configuration, and then AR view dot scene dot add anchor, which is for the body skeleton anchor. That's the anchor we are using here. And then the last one is AR view dot session for delegate method actually will be equal to self. AR view dot session, we will come back to that or those errors later on. And first thing what I'm going to do here after this is I'm going to declare a class which is for this anchor entity, body skeleton, all these stuff. Actually this error, not to avoid that, I'm going to create a class in order to initialize that entity. So let's say class body skeleton, and this will be of a class which is for the entity. Alright, and then I'm going to declare a var variable which is for the joints. It is of a string of entity and will be equal to an array, and then required init, which is for the body tracking init feature. So required init, and what I'm going to do is I'm going to, it is for a body anchor, and that will be of AR body anchor, and this have to be inside after this, and we are going to alright. So this is required init, and init, what I'm going to do is for this a body anchor, and inside the body anchor I'm going to override for the super init dot init, and init, first of all what I'm going to do is create entity for each joint in skeleton. Alright, so what I'm going to do here is I'm going to create each anchor, creating each anchor for each skeleton in order to do that for each anchor, which means for each joint. So it will be multiple joints, so each joint name in AR skeleton definition dot default body 3D dot joint names. So each joint name, let's make a default values for each appearance. So inside that, let's say let joint radius, which means what I'm using here is joint radius of a sphere type. It's for the size actually, so it will be say 0.03. You can increase the radius whatever you like to. And next one is a joint curl, and it's of a UI color, and you can name yellow, green, red, whatever. Like I'm using here a green, let's say green. And next step is I'm going to create entity to add whole joins to direct parent entity. So what's going to do here is let join entity will be equal to make join with the radius and color. This will be joint radius, which is we declared now, and the color will be of a joint color. Alright, so that's make join, and then what I'm going to do here next is joints will be of actually that joints we're going to declare that's why the error there. We will come back to that later on. So let's say join name will be equal to the join entity, and then the last line will be of self.addChild, and the addChild will be of joined entity. Okay, and the last line after this is we are going to update all of the above. So let's say left update with body anchor, alright. So after this we have a couple of we can see few errors there. In order to remove that, we need what happened here is, so we haven't declared about the joints, and we haven't declared about the make joints, what's happening there and all. So in order to do that, after this what I'm going to do is required init feature, which is it is actually which is for init not being implemented if in case. So let's say print there init has not implemented. Alright, and come back to the next point is we are going to write a make function for the make joints, which is I have written here a make joint with all the stuff. So let's say make joint, and here I'm using the radius and as a float value, and the color as well as UI color, and that will be of kind entity. Alright, and you can see that error from the make joint will disappear from now. Alright, so let's say let mesh will be equal to the mesh resource dot generate the sphere. Actually we are making, you can make whatever you like a generate a plane, generate a box. Actually the round thing which appears in each point is what we are expecting here. So it's I'm going to generate here a sphere and with the radius which I've set there like a 0.03, and from there I'm going to write here let material will be equal to simple material of the color, and the color will be of the color which we declare as green, and is metallic, going to say false, and I'm going to write one more like a roughness. I'm going to declare as 0.8. That's a material which I'm using to track the body actually. And let's say let model entity it will be equal to the model entity of with the mesh and with the materials will be of a array, which is I'm going to here use as a material. Alright, and then at last I'm going to return this entity. So let's say return model entity. Clear. So that's for the make join functionality. And the last one is I'm going to update the position of each joint at each entity. So in order to do that, I'm going to write here update function, which is for update each body anchor to that. So let's say func update with body anchor, and it is of AR body anchor. And in this function, what I'm going to do is I'm going to, let's say the root position will be of si empty make float. Actually it's nothing but we're going to track the position of this sphere model into our body. So in order to do that, I'm going to do here is let's say root position will be of simt underscore make underscore float, and that will be the float value, which is for the body anchor dot transform dot column dot 3. Actually we have done this about this in the previous video. We are trying to make the video with a robot as an anchor on that video, so I have discussed about this positioning of the anchoring system inside that video. If you haven't watched, please go through that. So okay, let's come back to this. So it'll be our skeleton definition dot default body 3D body with join names, and inside that, all right, inside that I'm going to declare if that joint entity will be equal to joints of join name, and let's say one more declaration. It is actually for the joint transform will be equal to the body anchor dot skeleton dot model transform, and the model transform is actually for the AR skeleton joining, AR skeleton dot join name, and the join name will be of raw value of the join name, raw value of join name. Alright, so after this I'm going to open there, and inside this let joint offset set will be of equal to simt underscore make underscore floats. Float will be of 3 joint. This is of joint transform, joint transform dot columns dot 3. Let's say form. Here also we will declare forum. Okay, so the next step what I'm going to do here is I'm going to join the each entity with a position. So in order to do that, joint name, joint entity dot position will be equal to the root position of the body plus joint offset. So this is from the main body to the uh, sphere which is going to track. Okay, so joint entity uh, dot orientation will be equal to transform of matrix, and here I'm going to use as a joint transform dot rotation. All right, and is metallic third comma. All right, and body entity root position plus joint offset not be applied. Okay, we'll come back to that. Okay, all right. Here actually the joint position for the root is said to be binary operand, which is for a sim float 2. Actually I made a mistake here, that have to be a float 3 in order to position in the right way. So the error got disappeared from there, and here we can see this is a godlet, so you need to return here. Actually if it in case the device not support means that will end over here, and this session will be never called if in case the guard haven't succeeded. The final step is I'm going to update each character. Actually I need to update the character in the session, which means each movement will be tracked. That's what I'm going to do here. And next is, let's say func session, and did update with anchor, and did update anchor. I'm going to type here what is for anchor. In anchors will be, it's actually in order to track the local body. So let anchors for anchor in anchors, and then I'm going to initialize, let's say if let the body anchor, which means if the body can be tracked in case. So that's why it means that if it haven't able to track the anchor, it won't get certified in this condition. So let's say anchor as AR body anchor. So I have written if let body anchor is equal to anchor as body AR body anchor. It means that if in the update condition it's going to check whether this body tracking is able to get updated or not. If in case that happens means this will start doing inside this. So let's say with the updated anchor, which means if it's satisfied we can print here updated anchor like. Alright, and inside that what I'm going to do is, first of all, let's say let skeleton in order to track the root joint positions. So if you want to print that joint positions in future or in your project, you can do it in a similar way, like if let skeleton will be equal to the body anchor. This is actually for tracking the root joint positions in the right and the left. That's what it means. So let's say body track dot skeleton, and then what I'm going to do is let root joint transform will be equal to the skeleton dot model transform, and it's for the root. Actually here should be let constant. If you want here to be a left hand or right hand, also you can do that straight away. Alright, and just made it for the root actually. And if say let root joint position will be equal to SIMD underscore mate underscore float 3, and this float 3 will be of root joints transform, and I want this to be in of columns dot 3, and then what I'm going to do is write print the position to be of here. Let's say if I want the right hand position, if you want the root, you can print here for the root. If I want the right hand position, I can print it here with this root joint positions. And if I want to change for the right hand, what I'm going to do here is right hand joint position. Let's change the name as a right hand joint position. Copy that over here, and the final thing, I'm going to copy that here as well. That's it. And they should be of cursor wrap. Okay, so next thing I'm going to type here for the left hand position, which is actually here we need to change the root as well to the right hand. Alright, that's done. So let's say let left hand transform will be equal to the skeleton dot model transform, and that model transform is for the joints for the left hand. And let's say let left hand offset will be equal to SIMD underscore make underscore floats 3, which is off for the left hand transform dot columns dot 3, and then what I'm going to do here is let left hand position will be equal to the root equal to the right hand position plus left hand offset. And here you can print the left hand positioning in offset actually while it, okay. And so let's say print, and what I'm going to print here is so let's just say left hand position, and that position will be declared from here, which is of left hand position, and that will be printed over there. So here also you need to make this as force wrap. So this is how the tracking for the left hand and the right hand. And if you want to root back to the main root position of the body, we can change to the root as well, back to the root as well. And let's say root, you can run it from there as well, or if you want to change the root, you can change to the root as well, back to the position. So alright, and here also you need to change the root. You can make use of both these and try what make the difference. Alright, so the last one is I'm going to change back to the zero joint position. That's all. And the final thing is what I'm going to do is if let skeleton, that's the main function actually we are going to implement at the end, and this is of let skeleton will be equal to body skeleton, and inside that what I'm going to do here is I'm going to, or if already exist with the body joints, which means if the joint is already existing, so let's say already exist. So what I'm going to do here is it's going to update the joints according to the movements. That's what's happening here. And inside that, let's say skeleton dot update, and what I'm going to update is update with the body anchor. That is for if condition, and if say else, it's going to initialize for the first time. So this is for the first time initialization. And what happened here is, let's say if let skeleton will be equal to body skeleton, and that body skeleton is for the body anchor, and then what I'm going to do here is body skeleton will be equal to the skeleton, which is for this AR skeleton 3D model. And then I'm going to do here, final step is the body skeleton anchor dot add child, which means it will be adding a child in order to track the skeleton. Cannot call the non-function skeleton for body anchor. So this is for the capital body. Alright, that's all, and we have done all the steps. So that's all in this thing, and this is going to have track all the offsets from the main body object, and this is all there we have. And if you go to the info.plist, this is already having a privacy with camera usage description, which means if you run this from here, it will be asking for the user camera permission, so we just add a small string there. So this app requires camera access. Alright, so as soon as you run to the real device, it will be asking for the camera permission, and then it will going to the AR view straight away, and it's going to track the body. So let's run and check what we have done so far. This is the final output, and I have here this body tracking. It's asking for the permission in the app, and this is which I tried with the static object in order to track the body. It won't move any motion, so it will be static there. It's a pre-recorded one, and another I have here with the real body tracking. There you go. That's all, and this is all about in this video, and in upcoming episodes we will try to make the hand posing gesture in order to call some functions by moving with the hand or fingers. We will try to call some functions. That's what it means. So that's all in this video, and thank you for watching. Stay tuned.